Welcome back. So now that we've got box plots and you've got five number summaries, what do you do with them? What do they mean? What good are they? Well, the main idea here is that we can use these to summarize the distributions. So I'm going to make the circles smaller for a minute so they don't distract us. You can drag that thing right there and make them real small. Now we've got that, and then I'm going to get rid of that reference line for a minute too, just so we're just seeing what we see. So here we have two box plots. There's a few different things to notice about these. First of all, these divide the data into what are called quartiles. That means 4 parts, quart meaning 4. So 1, 2, 3, 4 areas here, and 1, 2, 3, 4 areas here. That's useful because in each of the areas there is about 1/4 of the data. It sounds kind of funny because it looks like this area is bigger than this, and this one's bigger than that, and that one's the smallest of these, and this one's the smallest of all of these. But in fact, if we look at the dots, I'm going to make the dots a little bigger, and we count the number of dots that are in each area, it's about the same, even though they're more spread out. And so that's the thing, like this area here has about the same amount of dots as in this area, but they're way more spread out, as you can see, because of these outliers out here. So that's one thing that's kind of nice. It basically shows us 25% of the data, that's 1/4, in each area. Now, another thing it does for us is it provides a measure of the spread of the data. And the way we measure that is this distance from here to here. Also for this one, from here to here. That distance from Q1 to Q3 is called the interquartile range, or the IQR. You're going to see that in your book. We can measure that in a couple different ways. First of all, we know that Q1 was 20, this right here is 20, and that is 28. So the distance from 20 to 28 is 8. So the IQR of this is 8. Nothing you can do if you're not too sure of that, or you want to do it a different way. You can use the ruler here in Tinkerplots, and you can move that so that it's sitting right on the edge of the box, and you can move that one so it's sitting right on the edge of the box, and voila, notice it says 8. The IQR there is 8. We could do the same thing down here, and we notice the IQR here is from the IQR starts here at Q1 and ends at Q2. And remember, we know that's 17 to 20.5, so that means that's 3.5. The IQR is 3.5 miles per gallon. This one was 8 miles per gallon. What does that mean? That means, and it should be pretty obvious, that this one is more spread out and has more variation than this one, because the number that we measure the spread with here is 8. The number for here is 3.5. That's a bigger number, so that means a bigger IQR, which means a bigger spread than here. So that's good. It also means, if we think about this a little bit, that automatic transmission cars are less varied. In other words, because the IQR is smaller, the spread is smaller, and that means they're more like each other. And you can see that. See how all these automatic cars are all clumped together? As opposed to up here, where the manual transmission cars are more spread out. They're more unlike each other. Yeah, there's a pretty good clump here in the middle, but overall, they're way more spread out, so they're not as like each other as down here. Another thing that the box plot, or the 5-number summary, tells us is it gives us a nice, convenient way to talk about typical range. The area from here to here, again from Q1 to Q3, is the middle 50% of the data. Remember, 25% here, 25% here. So that means this is altogether about 50% of the data. That's a pretty convenient way to talk about the typical range. So let's summarize this in written form here for a second. IQR for manual transmission distribution is 8 mpg. The typical range using this box plot is 20 to 28 mpg. So boxplots, we of course could do the same for the automatic transmission, but I think you get the idea. So boxplots are a very convenient way to be doing this, and it then enables us to compare. One other observation, or maybe two other observations we might say. If we were going to compare these two distributions, I personally would argue that manual transmissions are getting better gas mileage than automatic transmission. I would first say that the center is about 23 here, measured by the median, as opposed to 19 here. That's a 4 mile per gallon difference, which is, fairly significant. Also, I might note that the lower 75%, so look at this 75% here, sorry, 25% here, 25% here, 25% here, so that's 75% right there, is almost entirely below the upper 75% of the manual transmissions. So that means that most, 75% of, which is most, automatic transmissions get less good mileage in the city than 75% of manual transmissions. Not quite, because there is a little bit of overlap right here. You can see that overlap right here, a little bit of overlap. So you can't quite make that claim, but it sure is a lot of the, certainly over 50% of these cars get less good mileage than 50% or more of these cars. So the box plot is actually telling us quite a bit without even having to look at all the dots. Hope that helps again, and I look forward to seeing your questions online. Thanks.